So you can cross out A. You can say B, the parts used in the watches are rarely defective. Well, that's not an assumption that he used to reach his conclusion that 12% of the 750 were defective. So you can cross out B. When we look at C, it says the sample, which was the 25 watches he tested, was representative of the population. And yeah, that kind of makes sense because after he saw that 3 of the 25 were defective, he made the assumption that 12% of the 750 were defective. So we can say that's a good answer. And then the watches were made by the same employee. Again, that doesn't really have anything to do with what the question's asking. So you can cross out D and figure out that the answer is C. Does that make sense to everyone? Okay, next question. The letter W is in the center of the diagram below and represents the location of the wireless router for internet access in a square house. The router provides access to the area represented by the dotted circle in the diagram below. This circular area has a diameter of 20 meters. So to the nearest tenth of a meter, the distance x from the router to W, the middle of the outside wall, is what? So again, I'm going to just redraw this out because I don't have this on paper. Pretend that's a square. I'll try and make it better. Okay. So it says the first thing that the question gives us is that this circular area has a diameter of 20 meters. So we know from the center to the outside of the circle is 20 meters. And then this is x, which is what we're trying to find. So kind of similar to the question that we did with the archway above the waves, we see that here we can also see the diameter is represented. So therefore this length is also 20 meters. And then again, kind of like the other question, we now have a right triangle here. So we can take that, make it bigger. So we know that this side length here is 20 because that's the diameter. This side length is x, which is what we're trying to solve for. And then similarly, this side length would also be x. And then you can see that because W is in the center. So if you look at the square, this is the center. Therefore, this length and this length must be equal. Does that make sense to everyone, how I made that assumption? So if you go back to our right triangle here, this means this is x. And then again, we're going to use Pythagorean theorem. Here it's just a little different because we don't have all the values. So x squared plus x squared equals to this length squared, just times squared. And then here you can add these two together to help you simplify it. So here we have 2x squared equals to 20 squared, which is 400. And then we can divide by 2 on both sides. X squared is equal to 400 divided by 2, 200. X is equal to the square root of 200. Now, put that in your calculator. And so x is equal to 14.1 meters, and so the answer is D. The area A of 4 square carpets is shown below. Which carpet will cover the most floor area without touching a wall when it is laid flat in a square room that has a width of 4.5 meters? So the first thing that we want to do to see which one of these carpets you could possibly use is see which one would actually fit within 4.5 meters. So to figure that out, if you recall, the area of a square is equal to the side length times the side length, so the side length squared. So we have all of these area values, and I'm going to start with the biggest one because we're trying to find the largest one. So let's start with carpet 4. So the area is 22 meters squared 22 is equal to s squared. So what is s in this case? S is equal to the square root of 22. And that's about 4.7. So that is bigger, the side length would be bigger than 4.5, and therefore we would not be able to fit it in the room without touching the wall. So you can eliminate carpet 4. So the next biggest area is carpet 2, which has an area of 18.5 meters squared. So we do the same thing. 18.5 is equal to s squared. This is equal to s is equal to 0.4.3. So that one does fit in our room that has a width of 4.5 meters. And because it has the next largest area, we can safely assume that this is going to be the carpet that will cover the most floor, because if we went to smaller areas, then the side length would keep on getting smaller. So that's why we can assume it's carpet 2. That is going to be our answer. So the answer is B. Makes sense? Okay. The cost of renting a car includes the base fee and a charge for each kilometer driven. The graph below represents the total cost of renting a vehicle at 4 different rental companies. Which rental company has the smallest charge for each kilometer driven? So at first, I think the PAT creators probably want you to think, oh, the answer is obviously this one, company W, because you end up paying the least for it. But you have to remember that there's a base fee for before you add on the charge for each kilometer driven. And because the question asks you which has the smallest charge for each kilometer driven, not overall, we have to take that into account. So I guess we'll start with company W. We can kind of approximate and see, okay, so this is 4, so it goes up in 20s. So this looks to be about halfway between these 2 points, so we can assume that this is 20 plus half of 20, which is 10, so $30. So $30 per 10 kilometers for company W. Which is equal to $3 per kilometer. Company X. Again, for company X, it starts at 25 and it goes up by 10 and another 10. So that's 35. So 35 minus 25 is 10. So that's $10 per 10 kilometers, which is equal to $1 per kilometer. Company Y. That is, this one's kind of hard to see. So we start at 40 and we go to, I'm gonna guess that's around 50. A little bit more than 50, let's say 55. So 55 minus 40 is 15. $15 per 10 kilometers. So $1.5 per kilometer. And finally, company Z. Look again, this is kind of hard to see, but we can see this is not even going up a full increment of 10. So it's less than $10 per 10 kilometers. And so we know that it's smaller than company X, therefore we can see that company Z is going to be the company that charges the least amount per kilometer. Does that make sense? Another thing with questions like these, where you actually have to do all the work of calculating everything, a really good method to use sometimes is to start with the very last one and then go up, because sometimes they want you to waste time as you're going through it. So if you start with the very last one, like in this case, if we had started with company Z, it would have been more easy for us to see what the answer was. So that's just a technique that you guys can use. Okay. For examples of wind turbines are shown below, considering the blade length and the height of each wind turbine. The two turbines that are proportional to each other are turbines length and length. So this isn't a super difficult question, it just takes a bit of a while to look at it. So proportional, I guess, shapes, you can say are shapes when you multiply it by the same ratio. When they have the same ratio, you use the same ratio to get to the next side length. So for example, I'll just do an example here. This square is proportional to this square, because if this side length is 1, this side and this side length is 2, then this side length is 1 and this side length is 2. Like, if you would multiply it by 2 to get to this, so that we can say that they're proportional. So basically we're looking for which of these two turbines can we multiply by the same number to get so that they are proportional. So, I guess a way that you could do this, a method, is you can use division instead of multiplication to solve for it, if you're not sure right away. So for example, if you want to see if if turbine 2 and 1 are proportional, we can do 18 divided by 10, which is equal to 1.8. And then we see, do we get the same answer when we do 30 divided by 18? 30 divided by 18 is not 1.8. It's about 1.6. So because we can't multiply both of the side lengths by the same number, they're not proportional. And I guess I'm trying to think of a faster way to do this question. I guess by looking at it, you can kind of see if you don't, like, you could go through the division process, or what you could do is you can also see, like, hey, 30 divided by 45, that's a nice number to look at. 30 divided by 45 is equal to 2/3. And then if we do 18 divided by 27, that is also simplifies to 2/3. And because they're the same numbers that we're using to multiply each of the side lengths, then we can say that they're proportional. And so it would be turbines 2 and 3. Does that make sense? This is a fun question. Says the following 3D object is composed of identical cubes. The volume of each cube is 8 centimeters cubed. What is the total surface area of the 3D objects shown above? So this is more of a visualization question, I guess. These can be difficult for some people. But okay, we know for the volume of a cube, that's equal to the side length cube. So 8 is equal to s cubed. S is equal to the cube root of 8, which is 2. From there, we can find the surface area of one single square, which is s squared, equal to 2 squared, which is equal to 4. So we know that, for example, the surface area here is simply 4 centimeters squared. So now we need to figure out how much surface area does the whole 3D object have. So you see on the top there's 1, 2, 3, 4, 5 squares. And so we can assume on the bottom there's also 5 squares as well. So that makes for a total of 10 2D squares, which is, and then we can use that to multiply for the surface area of just the top and the bottom. 4 times 10 squared equals to 4 centimeters squared. 40 centimeters squared. Okay. And from here, this is more visualization. I guess a simple way to think of it, because we've done the top and bottom, we just have to find out these side pieces. So because we know these are cubes, we know that this, even though it looks like a rectangle, it is actually a square. And for each of these, there's 3 sides. There's one on the back. And so we have 4 units that are like this. So the 3 sides times the 4 units that are like this makes for 12 squares in total that are like that. So you can calculate the surface area of the sides. 4 centimeters from there, to find out the total surface area of the 3D object, we just add the two together. So 40 centimeters squared plus 48 centimeters squared makes 88 centimeters squared. And so the answer is C. Does that make sense?
I'm back. This question is just your classic algebra question. Maybe you can do it even faster than me in your head, but let's just have a race. The important thing here, I think, is just make sure you don't get messed up with the distributive property. Remember, the number outside of the parentheses distributes over both numbers inside the parentheses, so I'm just going to rewrite this. And we're trying to solve for x. So again, the 3 here distributes across both parts of the parentheses. This is a really common way to get tripped up, is forgetting this fact. So we have, well, you could do it a bit nicer. Personally, I don't really like the 1/2 there, so I'm just going to multiply both sides by 2. So yeah, we have something that looks like 2x minus 1 equal to x plus 6. Now we don't have to do the distributive property on 2 things, and we can just do it on this one thing, which is nice. So we get something that looks like 12x minus 6 is equal to x plus 6. 11x, basically combine like terms, add 6 on both sides, subtract x on both sides, something that looks like that. Yeah, x is equal to 12 over 11, which is b. Is that okay? Question shouldn't be too bad. This is a similar algebra question. In this question, we have some surprisingly talkative students that actually answered. Alright. So really it's just a different way of telling you to solve for what the expression is going to be, right? So you have 3x times 4x minus 6 all over 2 times 3x. I think the nice thing to note about here is that, sure, there's parentheses here, but since everything's multiple, you can multiply everything. I think the right word is like everything's commutative or something. So you can cross out the 3's, cross out the x's, you get something that looks like 4x minus 6 over 2. You notice that both of these numbers are divisible by 2, so you divide it by 2, which gives you something that looks like 2x minus 3, and that's what student 2 says, so the answer is B. That one wasn't too bad, right? Let's go to the next one. This one's pretty tricky, actually. Okay, so I think the first thing that's really important to realize is what it's asking. It's asking for what values P and Q would result in the lowest value. So the lowest value doesn't mean the value closest to 0, it means the value that's the most negative. Essentially, that's basically what it's saying. And I think the nice thing to do before you actually solve the problem is look at the answers. All the answers have magnitude 2, right? So basically what it's asking is what signs of P and Q will result in the lowest value. All right, So the first thing to realize is p cubed. What does p cubed mean? Or I guess it's 2 times p cubed, but 2 is positive, so it doesn't really matter. We know multiplicate or exponentiation again is just repeated multiplication. So it's just p multiplied by itself 3 times. So let's just say, a thought experiment. What if p is positive? Okay, p cubed is also going to be positive, right? Positive times a positive times a positive. What if p is negative? Now this is the important part. It's not like a square where the negatives cancel out, because if p was negative, then we would have 3 negatives, right? The 2 negatives cancel out, so you have 1 negative left. So if p was negative, if p is negative, then p cubed is also negative. Great. So I think you would realize then to obtain the lowest value for that expression, you would want p to be negative. And the only answers that sort of correspond to that are A and C. So now we want to know which value would get I guess you would want the highest value for q, for 6 divided by q, because it's negative 6 divided by q, if that makes any sense. So if q was positive, then 6 divided by q would be positive, because q is it's just a term. There's no exponentiation. There's nothing funky going around there. So if q is positive, then negative 6 divided by q is also positive, or it's negative, my bad, which is good because we want the most negative thing. So we want q to be negative, or q to be positive. Holy crap. And the only answer there is C. That's the right answer. Yeah, okay. C. Sorry, messed up the explanation. Is that okay? It's extremely complicated. Not really. It's just really easy to mess up. But yeah, just remember that cubing something does not actually change the parity or change the sign. Okay. Next question. This one's a kind of nice question. It's not too difficult if you look at it in a nicer way. So what the question is asking is, you want to find the question mark. You want to find the height of this entire shape, and you know the area of the gray cubes, and you know the area, or not cubes, sorry, squares, and you know the area of the black squares. Okay, so I think there's multiple ways to do this. Of course, there's multiple ways to do anything, but the way that I did it was, I noticed that the height was 3 of these gray squares plus 1 of these black squares, right? So, well, right now we only have the area of each of these squares, so we want to find the length of these squares, because it's the 3 lengths of the gray squares and 1 length of the black square. So to do that, we have to use the good old formula for the area of a square. The area of a square is the side length squared. So if I had 77.44 centimeters squared, the side length is just the square root of that. Can you use your calculator? I don't like these questions, to be honest. How do you use your calculator? Okay, got it. I got it. Thanks. Okay, so this ends up becoming 8.8. And this is of the gray square. And then the black square is, I'll just put subsets there to differentiate each of them. Pretty sure that's 2.1. Black. So again, the total height that we're looking for is 3 times the gray square, so 3 times 8.8, or the length of the gray square plus 1 times the black square. (26.4) plus 2.2, 28.6. I'm not good at mental arithmetic, but hopefully that was right. So the answer should be A. Yeah. Anyone have any questions with that one? Okay, next one. This one is a bit fun. It's a bit annoying for me to actually solve this question because I have to redraw this shape. I don't really want to redraw this shape, but basically what the question is asking is, you have, this is supposed to be like an incomplete shape, and you want to find what the shape looks like essentially after you reflect it about this line of symmetry. So, and then you want to find how many dots are actually within this shape after you actually make that reflection, or essentially you make that reflection. So it's a lot easier if you actually have a piece of paper and you can actually write on it. I'm just going to be really lazy, so bear with me. But the way I solved this, I thought I was kind of clever with this, to be honest, but instead of reflecting this shape, because this shape is kind of annoying to reflect, right? I would rather just reflect the points. So because personally for me, it's a bit easier to see where an individual point might go upon reflection. So you know, this point would probably go over there, that is not within this shape. That point goes somewhere over here, also not within that shape. This point goes over there, within that shape, that's 1. That point goes here, that's not within the shape. This point goes there, 2. This point, I think it actually goes here. Yeah, I think so. Does it? No, it doesn't. Okay, never mind. I lied. So it does not go there, it goes over here. This point, I believe it goes here, which is 3, and then that point goes out. So I believe the answer should be 3. Let me make sure. Yeah, okay. Sorry I did such a sketchy way, but does that kind of make sense? All right. When you're actually doing the test, I would recommend just draw it out. Obviously that's going to be way better than just sort of, you know, moofing it until you have like a sketchy solution. Okay, so this is the next one. This, if you haven't learned this technique, you learn it in the curriculum, but if you haven't learned the technique, then it might be a bit difficult to solve because it's basically asking you how the technique works. And it's like, what you're trying to do is you're trying to model division with like, I forgot what these are called. I think they're called like unit cubes or something.
Algebraic tiles.
Yeah, algebraic tiles, that one. And I don't really like them, but personally, what I did with this one was, the first thing I looked at was, what's the thing that I'm trying to divide? 6x squared minus 3x, right? So I need 6 of these. Only A and C have 6 of them. And then I need 3 of these negative x tiles. And be careful with the negatives, because you might notice that these two are the exact opposites of each other. So we need 3 negative tiles. So we know, well, both of these actually have 3 negative tiles, which is pretty nice. But we're dividing by negative 3x. And if you look at, it's nice with algebraic tiles, the way they actually modeled it, because it's similar to how you would do long division. So if I wanted to divide something, let me erase this. If I wanted to do any form of long division, you normally have your thing that you want to divide here. The thing that you divide by, here, and then your quotient up here. I forgot literally all of these words, but yeah. So we want to divide by negative 3x. So, and that's on the right side. So which one of these is negative 3x? Well, it's this one. So the answer is A. I personally don't like algebraic tiles. You never use them after grade 9, so I don't know why they teach them, but it's a way of understanding polynomial division, I guess. Oh, does anyone have any questions? This one's actually kind of complicated if you haven't learned it before. All right. Okay. So I'm not sure if you can see, the numbers are a bit small here, so I'll just redraw it. Basically what you have is you have some prism of which you know the shortest edge is 64 centimeters, and each of these edges are given to you, but they're given to you in variables. You're not actually given, the exact length of them, yet at least. Which one's the other one? This one. So they're all just different powers of some number A. So I think we can be pretty confident that A is greater than 1, so we know that each of these powers are in ascending order, magnitude-wise. So A squared should probably be our smallest, or what we would consider the smallest side. So if we just set that equal, 64 centimeters is equal to A squared. And what's the longest going to be then? A to the power of 4, right? This is going to be our longest. All right. I think, or the way I would solve this is, A to the power of 4 is A squared squared. So 64 centimeters squared. And punch that into your calculator, or if you memorize the first 12 powers of 2, then you get something that looks like 4096 centimeters squared, which is D. Does anyone have any questions? Do you want to actually punch that in just so that I'm not wrong?
It's right.
Great. All right. This one. This one's, it's kind of funky because I guess it's a bit of a logic question, but it's also just, you have to understand how, or they teach you how bias in surveys work and what is actually representative of a population. So the question is basically asking, you have a tournament with a lot of teams and you want to basically have a survey about the tournament essentially, and you have different ways of asking the teams how to, or like which teams to ask the survey, to give the survey out. So these are your options, and to be honest, they all represent a certain population, and that's what I think Alberta Ed calls it, like what populations it's representative of. So what we want to try to find is the population that these surveys, or we want to make sure that the representative population is all 16 teams. And also it surveys enough teams to get like a relatively, it has enough data points to get a relatively, what would the word be? Valid result? Yeah. So let's just take this one at a time. So one player from half of the teams. So you only take half of the teams, and then from each of those teams you pick one player. That's representative of half of the teams, but not very representative of the other half, right? So we could probably cross out A. So B. Actually, I'm gonna leave every fourth team that registers in the tournament. That seems kind of good. That's why you call systematic sampling, I believe. And it's not too bad because technically speaking, each team has a possibility of getting picked, right? Because it's technically random, but it's actually not that great. I'm gonna go with D because the right answer is C. But D is all the players and coaches from one randomly selected team. That's very bad, obviously, because you literally only have one team that says stuff for the entire 16-team population. So C, 3 randomly selected players or coaches from each team. So we have 16 teams, right? And you're picking 3 players from each of them. I think the first good point about this is that you have a lot of data points. You have 3 times 16 data points. And then you also have a technically representative population of every single team. So the right answer ends up being C, and the reason why it's better than B is because first thing is B, you only have technically 4 data points because you're only sampling the entire team and you're only sampling 16 divided by 4, which is 4. And then the second part is because you're only sampling 4, that's not necessarily representative of the entire population. So that's a bit of a complicated question, to be honest. I was stuck between B and C, but if you reason it out, I think you can eventually get to the answer of C. Does anyone have any questions with that? The reasoning is a bit complicated, to be honest. Okay. This one's not too bad. So Dale gets $180. I have a friend called Dale, by the way. He also earned, so of that $180, $45 of which he earned washing cars, and the other $135 he earned mowing lawns. How did I get that number 135? Well, I have a total of 180, and I want to find how much money he spent or he got mowing lawns. So I just subtract off the money that he didn't get mowing lawns, which is $45 washing cars, and you get $135. All right. So you now know he receives $9 per lawn mowed, and he earns $135 in total. So if you want to find how many lawns he mowed, then you want to divide your total by your rate, essentially, which is $135 divided by $9, 15, I believe. Does anyone have any questions with that one? That one's not too bad. All right, this next one. So what you have is you have a system of equations that you know are true, and you want to order each of these variable values, given that the system is true, on a number line. And it says -10 to 10 on the edges of the number line, but that doesn't really matter. All you really have to do is figure out what each variable is with respect to the other variables. So let's take it one at a time. Let's start with s equals q plus 1. Well, if we sort of just walk through what this equation is saying, we're saying s is 1 greater than q. So we can be pretty confident that s is greater than q, right? Yeah. And then your first inequality is q is greater than r. So you know q is greater than r. That was pretty simple. So you should probably figure out that in order, like increasing, the 3 variables should be r, q, and s, where s is the greatest because of just of the order of the inequalities. If you look at which number line sort of satisfies that, the answer is D. Any questions with that one? Next one. So Alice is your typical waiter that is earning less than minimum wage because the minimum wage has increased, I believe, from 2015. Yeah. And she also gets some money from tips. So basically you wanna, again, for some reason you wanna model the amount of earnings she gets in total per day if she works 8 hours per day. So what I think the most important thing here is that you have to realize that the money that she gets from tips is independent and doesn't matter from the actual wages that she gets. The tips are just sort of like an add-on. So how much money does she get purely from wages? You could say it's 12.5. This is her hourly rate multiplied by the number of hours she works, which is 8. And then again, the tips are just an add-on. So you just add the money from tips on the end. And you see the answer is A. Yeah, the answer is A. Okay. Does that make sense? This one. So you have two equations. They also give you a graph, and you want to find the point at which they intersect. Now, there's actually two ways of solving this question. One way is you could try to actually graph the expressions themselves, or the equations themselves. I wouldn't recommend this. A lot of the time I'm terrible at graphing things and I will make a mistake. So I think the better way of doing it is actually just solving this algebraically. And if you're not comfortable with solving systems of equations, probably should start getting comfortable, because it's a really important problem solving technique, I'd say, to know. So let's just write down what are the two equations we have. 3x plus y is equal to 17, and y is equal to x plus 1. We know if they intersect, right? If these two lines intersect, then we know any coordinate pair x, y satisfies both of these equations. So we know this y should be the same as this y. So we can do what we call substitution. And we can substitute the other sign of the equivalence into that equation. So you get something that looks like this. If you wanted to solve, and now just solving for x, you get 4x is equal to 16, x is equal to 4. You can already solve the question now, because you notice there's only one answer that has an x coordinate of 4. But if you want it to be, maybe extra, you have y is equal to x plus 1. 4 plus 1 is 5. So your ordered pair is 4, 5. C. Does that make sense? They give you a huge chart, but to be honest, I wouldn't recommend graphing it. Notice that this is 17, so the y-intercept is already outside of the page. So I'd recommend just solving this algebraically. Okay. This one tests your sense with numbers, but in reality it sort of just tests how well you can use a calculator. Of course, you don't have to use a calculator here, to be perfectly honest. You can just sort of look at each of these points. So for W, I'm going to use some notation that's not quite correct, but hopefully illustrates my point. W is a lot greater than 2 compared to 3, and each of these intervals is 2, so the mid interval is 1, so 2 plus 1 is 3. So W should be pretty close to 3, somewhere pretty close to 3. So what's the square of 3? It's 9. Is there any of those code numbers that equals to somewhere around square root of 9? We can see W is probably equal to square root of 8. So that's code 2. Right. The next one is x. X is pretty close to 5, but a lot further away from 6, right? So what's 5 squared? That's 25. So we know that it should be somewhere pretty close to 25. If we look at all the numbers, the only one that's possible is probably square root 27, which has a code of 7. All right, next one, y. Yeah, okay. So similarly, we do the same idea, but this one's a bit closer to the middle, but we still know it's closer to 7, or to 6, sorry. So you have y 5 less than times 6. So you know it should be somewhere close to 36. Yeah, but it should be less than 36. The only one, like the closest number that's less than 36, that's both greater than 5, that's close to 36, is number 8, which is root 32. The last one is z, which should be a bit bigger than 6, but a lot less than 7. So it should be greater than root 36, but less than root 49. There's only one that actually, there's 2 that actually fit there. It's root 37 and root 41. But what we notice is that z isn't like super close to 6, so we can be pretty confident that it's root 41, which has a code of 4. So the answer ends up being 2784. That makes sense. You could also literally calculate each of the values and then just plot them on the number line, and you would get the same answer. And it's a bit more direct. If you want to validate it, if you have extra time and you want to verify your answer, that's a great way of doing so. But if you don't have the time, you can just sort of guesstimate. Next question. This one's just algebra and kind of like distributive property. The important thing to realize is the negative distributes over every term within the parentheses. So be careful about that, because that's probably, you see a lot of the different answers. Each of those different answers are if you forget to distribute the negative somewhere. Minus 3x squared plus 8x minus 20. Minus. And we distribute the negative over everything. So we get x squared minus 5x plus 4 minus 3x squared minus 8x plus 20. And we can just cancel out these values. Negative 2x squared minus 13x plus 24. So the answer is A. Again, the only difficult part of that is making sure you remember to distribute the negative over everything within the parentheses. And then it's just combining terms, which you've probably done a lot of, or you probably should have done a lot of at least. So this question. Oh, and actually that was considered one of the extremely complex questions. Probably not because it was actually complex, but because I guess Alberta Ed finds that a lot of people make a mistake there. So don't do it. Remember to distribute. All right, so this last one, I think we have, I want to switch in 5 minutes. So this next one, we basically want to model the number of black shapes with the number of white shapes. The first thing that you sort of notice is that for each black shape increase, we have 2 more white shapes. So we should say like W is equal to 2B plus, I'll write that down. So we should know that W is equal to 2B plus something. We don't know the something yet, but it doesn't really matter because we notice that there's only one answer with the constant or coefficient of B as 2. And if you actually tried to plug in the values, which I would recommend if you wanted to verify it, you would find that this expression does, or this equation does model the actual table. So the answer is D. Okay. This one is circle angle laws. I'm not sure if you've actually learned about them before, and they're actually a little bit complicated too. But I'm not gonna teach them because it'll take a little bit of a while to teach. So if you don't understand it, I apologize. But hopefully, maybe you'll learn it on your own time if you're interested. So you have your big circle, and this is O. And you want to find angle X. You have this weird looking triangle here that makes it not very nice. Okay. So the first thing that I want to do personally is because I noticed that the angle X subtends this entire arc. If you don't know what subtend means, I apologize. And so I want to figure out the angle, the central angle here, because I know that this inscribed angle is going to be half of the central angle. But I can't do that yet because I only have this angle. I want to figure out this extra little isosceles triangle angle here too. And the nice thing we know is it is an isosceles triangle because these two are radii, so it has to be the same. So this has to be 75 degrees as well. We know the angles in a triangle add up to 180. 75 plus 75 is 150. So this angle has to be 30 degrees. Now this entire central angle ends up being 94 degrees plus 30 degrees, which is equal to 124 degrees. And by central angle theorem, because they subtend the same arc, you know that X is half of 124 degrees. Which is 62 degrees, which gives you an answer of B. Does that make sense? Again, if you don't know these angle properties, boo-hoo, I guess.
Expressions represents like terms. So this is kind of like the last algebraic tiles question that we did. Again, it's just if you've worked them in class before. So we know 3x, well that's going to be 3 of the black rectangle, so this is incorrect. Negative 6x squared, we know x squared is the big square, so that might be a little confusing. I guess you can kind of figure that out because these would be the big squares and these are obviously smaller, so this is not the correct answer. Then it gets a little bit more complicated, kind of. Negative 2 times 4x and this, are these the same? Well, an easy way to tell is that even if we have x here, that means there has to be x's here, and we see that these only have squares which are representative of 1. We don't have any x representatives here. So by that logic, and like crossing out A, B, and C, we can deduce that the answer is D. And you can always go back and check. 4 times negative 1 equals negative 4. So this is equal to negative 4x. And there are x's here as well. So that's why the answer is D, if that makes sense. math teacher did, so the exercise here is at 14.4 kilometers per hour. This is a little bit advanced, but I feel like you guys should be able to understand. For 3/4 of an hour, so if you multiply this by the number of hours that he does, 3/4 of an hour, you can see, I guess this is an easy way to make sure that you're doing it correct, is that the hours cancel out. So we're left with 14.4 times 3/4, which is equal to 10.8 kilometers. So for the portion of the trip that he rides at that speed, that's how much he's traveled at that time. Then for the next section, we just do the exact same thing. 13.2 kilometers per hour times 1/3 of an hour. So for this portion of the trip, he's rode 4.4 kilometers. So to find how many kilometers in total, we just add the two portions of the trip. 10.8 plus 4, that is 15.2 kilometers. So the answer is E. So this is one of the easier questions. So this is back to exponent rules. Which of the following rules correctly identifies the expression with the lowest value, the expression with the highest value? So I guess the easiest way to solve this is to put it in your calculator. But if you're low on time, you can kind of simplify it so that it's not like you're spending so much time punching buttons in. So for expression 1, so okay, so then we multiply the exponents, 2 to the 6 plus 2 squared. Okay, that's simplified version of expression 1. For expression 2, squared plus 4 cubed minus 4 to the 3 to 0. So you know anything to the 0 is gonna be 1. So we just highlight 4 squared plus 4 cubed minus 1. Then we do expression 3, which we really can't simplify any further because remember, there is no exponent law for adding or subtracting exponents. So from there, I think for me at least, the easiest way to solve this is just to put the simplified expressions into your calculator and figure it out. And then from there, you can figure out that the answer would be B. So expression 1 is the lowest and expression 2 is the greatest. And I guess if you're running really short on time and you do have to guess, you can also kind of look at it and see, well, 2 is lower than 3. And if we kind of look at our expressions, it still makes sense that, so like if you really had to guess and it comes down to it, you could just look at the bases of the exponents and you can kind of see like it would make sense if 2 is the lowest and 4 is the greatest. But always put into your calculator if you have time because you don't want to make any mistakes just in case. Any questions on that one? No? Number 1 represents a solution to 4 with 2x on this one. Okay, so for this, I guess the easiest way to solve it, okay, I'll just rewrite it. It's greater than 4x plus 8. So what we can do pretty easily here is divide by 4 on both sides. So 2x minus 1 is greater than 4x divided by 4, which is x. 8 divided by 4 is 2. From here we can, depending on what you like to do, I'm just gonna move this x to this side. So subtract an x, minus x, so x minus 1 is greater than 2, and then we can add a 1, x is greater than 3. And then another thing, so it's gonna be between A and B. Another thing to remember, which the teaching guys in class, is if your circle on your number line is colored in, that means that's included as one of the solutions. But in this inequality, it's not a greater than or equal to, it's just greater than, which means that 3 cannot be included in the solution because we don't have an equal to. Does that make sense? And so the answer would end up being A for 31.
The last one, right?
This one is the last one.
This was the last one.
Store owner pays sales clerk $12 an hour. Assistant manager pays blah blah blah. The total how much money is paid to the 3 employees in 1 day. Okay, this is a bit of a more complicated question. So, how much money is? Okay, so I guess it's not that complicated. So we're trying to find out how much money in total is paid to the 3 employees. So we can calculate the amount. Let's start with the amount that the store owner, the sales clerk gets in 7.25 hours because we have the actual value of that. So he would earn 12 times the amount of hours he works, 7.25 hours, which is he would earn $87 for the sales clerk. Now, from there it says the assistant manager of the store earns 1.5 times the clerk's hourly wage. So rather than going back to the 12 hours and multiplying that by 1.5, we can just take the amount that the sales clerk makes and multiply 87